Hey guys, we're doing another chapter 6 video today, and topic is 6.6 if you want to write that down, and we're going to work on how can you find discounts. So this is kind of like the real life math, so to speak. Like this is the stuff you're going to use in your day-to-day life when you go shopping or you're in the store and you're trying to decide if something's a good deal or not a good deal. This is what it's going to be all about. So today we're going to focus on what a discount is. When you get to the store and you find out that there's a sale on something, how good is that sale and is it still worth your purchase? So we're going to try some problems, and in our notes we're just going to write example 1 to kind of get started. And here is kind of our setup. You're at the store and the cost of something you want to buy is $415. There's a sale today and the sale is 30% off. So the question is when you go to pay for your item, what's the actual price you're going to be paying? So you might take a moment to pause the video so you can write down the 3 facts. The cost is $415. The sale is 30% off, sounds pretty good. And the price is unknown. That's the part you want to figure out because you don't want to show up to the register and realize you really didn't have enough money to pay for it still, or it wasn't as good of a deal as you thought. So that's what we're going to figure out. So how are we going to do this? Well, let's go with our double number line strategy that we've used in some earlier videos. I'm going to draw a number line that goes from 0 to 100%. And we've done this before. And what I know right now is that if 0%, then I'd be spending $0. But the cost of our item is $415. That's the full price before it's on sale. The sale is it's 30% off. So we actually get to take off 30%. So we're not going to pay 100%. We're going to pay 70%. 100 minus 30 is 70%. The question is well, what's the price if I'm only paying 70%? So this is kind of our setup. If you look at our number line, we've got it from 0 to 100, but we're only paying at the 70% mark. Out of $415, I got to figure out how much money off do I get to take off. So 70%, let's convert that to a decimal. I'm going to move my decimal point 2 times over. That makes it 0.70, or 0.7 if you prefer. And what I'm going to do with that 0.7 is I'm going to times it by the $415. This is what I would do in the store. I would pull out my cell phone real fast, pull up the calculator, and I would do my price, $415 times 0.70. And if you have a calculator handy, you should type it in and see what you get. 415 times 0.70. Kind of see what you get. And I'm putting it in and I'm getting this, 290.5. I'm going to call that 0.50 since I'm talking money. So what did I just find out? Well, I just found out that I'm going to be paying, instead of $415, I only have to pay $290.50. That's my price. So that's what's going to replace those question marks on the number line there. Okay, so there we go. We got our first solution. Let's try another problem. Example 2. All right. Fleur wants to buy a birthday present for Mrs. Neer. Oh, isn't that nice? And Fleur is pretty nice. She's going to buy me a new Xbox. So that's awesome. Thanks, Fleur. But there's a sale today. When she goes to buy it, it's 10% off. So let's figure out how much Fleur is going to pay for my present. So guess what? She paid $207. And we want to know what was the original price before the sale. How much was the Xbox before she saved some dollars? So let's figure this out. Our facts are this. Our facts are she got a 10% off sale. She paid $207. And we want to know what the original price is. So let's get this set up on a number line. So our number line is going to go 0 to 100%. And what we know is 0% would be spending $0. We do not know what 100% of the cost was, but we do know that she took 10% off, so she saved 10%. She only had to spend 90% of the price, and that was a price of $207. When she went to pay, that's how much she spent. So the question marks are, what was the cost when it was 100%, when there was no sale? That's what we're trying to figure out. So it's kind of a reverse problem. It's a little different than the last example. And so what I'm going to do is I'm actually going to label this reverse the process. We're going to undo the work. So what do we know? We know that we are trying to solve for the 100%. It's our mystery number. In algebra, we say mystery numbers are x. So we're trying to solve for that x on the number line. Now, 90% as a decimal is 0.9, and when you move the decimal over, so 0.90 or 0.9. And what I'm going to do with that 0.9 is I'm going to realize that when I times my price of my Xbox times 0.9, I get my sale, $207. So what do I have to do to solve for x? If multiplying the price times 0.9 gives me 207, then I got to divide the 0.9 away, treat it almost like an algebra problem, really, is all I'm doing here. And when I divide by 0.9, 207 divided by 90% divided by 0.9 is $230. So the original price before the sale was $230, but Flor saved a bunch of money. She got 10% off. That was her sale price. So she only paid $207. But originally, before the sale, it was $230. And that's our answer. Okay, your turn. You're going to try one of these. They're a little tricky. Here's the story. Brenda wants to buy Mrs. Neer. Everyone's buying me presents. This is great. Brenda wants to buy Mrs. Neer a present for being such a nice teacher. And she's going to give me a little bling to wear in the classroom. Don't you picture me totally wearing this all the time? So the necklace is on sale. It is 30% off, and Brenda bought it for $45. The question is how much was it originally before the sale? So right now, I want you to pause your device and see if you can set up a double number line and solve for what was the original price of this necklace before she bought it on sale. Go ahead and try. Okay, you ready to check your answer? Okay, so here it is, double number line. Our facts are there was a 30% sale. She spent $45 on a necklace. So we're going to set up a number line 0 to 100%. 0% means $0. We're going to label that she got a 30% off discount. So we took 30% off the price, which means she only paid 70% of the full cost, and that was her $45. The question was, what was it originally when it was 100%? That's our X. So again, we're reversing the process. In the store, what we would normally do is we would take whatever X is, the price, and we times it by the 70% to figure out the sale. So 70% as a decimal is 0.7. So what we would do is we'd take the X price and we times it by 0.7, and our answer would be $45. That'd be what we're paying. So what are we going to do? We're going to undo this process by dividing the 0.7 away. $45 divided by 0.70 or 0.7 is about, I'm rounding here, is about $64.28. It was a longer decimal than that, but I went for a rounding answer here. So originally, the cost of that necklace was $64.28, but she got a deal. She got 30% off, and she only had to pay $45. So good deal there. All right, so let's try one more here, example 3, and let's go with these as our facts. We're buying something at the store, and the cost of the item is $12, but there's a sale, except I can't remember what the percent off is for the sale. But the price when you go to the register is you're paying $4.80, so pretty good sale. You're spending a lot less money. Let's set this up on a double number line and figure out what that percent sale is. So we know that we go 0 to 100%. We know 0% is $0. We know 100% is the full cost of the item. The item costs $12, but it's on sale, and we are going to mark it as only $4.80. Pretty good deal. So the question is how much percent off is that? What's the percent off of 100 that we paid? So to figure that out, I'm going to think of the top of the number line as, well, how much did we take off of $12? $12, if you subtract $4.80, is $7.20. So we took off $7.20 from the original price. That's how much money you saved, $7.20. So what percent is that? Well, $7.20 out of the $12 cost, we can divide. 7.20 divided by 12 divides down to 0.6. And if we move that decimal, that's 60%. That means we saved 60% off. This is a huge sale. 60% off meant I saved $7.20. And that answers our question. All right, so in class we're going to practice these. These are all called discount problems because what's happening is there's a sale and we're discounting the item. We're taking money off. So the question is what percent are we taking off, or how much money are we saving, or what's that final cost of that item? So that's kind of what we're working on. And really just trying to set up these number lines and practice with them some more. So thanks for watching, guys. I will see you in the next video.